Hi, this is Mrs. Aselson here talking with you about independent versus dependent, and this is just a review. We're kind of circling back to probability, which we did before. When we talk about probability, we have two types of events. We have independent events and we have dependent events. When we talk about independent events, these are events that do not affect each other, and the denominators don't change. Remember, those denominators are your bottom numbers, so those are not going to change. And then you have dependent events, and these are events that do affect each other, and the denominators will change or do change. You could say either way. Okay, so let's review some that we did. So we did this a few weeks back, and now we're just circling back. So let's try and get it back in our brains again. Miss Meyer reaches into her sock drawer. She has 4 pairs of white socks, 9 pairs of gray socks, and 3 pairs of black socks. She randomly reaches in and grabs a pair of socks. The next day, she grabs another pair of socks. What's the probability that she draws out white socks both days? So the first thing we're going to find is her total. So she has 4 pairs of white socks and 9 pairs of gray socks, 3 pairs of black socks. I'm going to add all those together. So my total number of socks are 16. She has 16 pairs of socks in her drawer. Okay. What they're asking is, what's the probability that she draws out white socks both days? So this is my first day and this is my second day. Remember, we learned before that when we talk about we're going to multiply. Okay, so on the first day, she has 16 pairs of socks in her drawer. But if she wears one of those pairs of socks, the next day she's only going to have 15 pairs of socks. If she wants white both days, she wants white the first time she draws socks and the second time she draws out socks. Okay, so when we're talking about white, I'm going to look back up in the reading and it says there are 4 pairs of white socks. So I'm going to start with that top number being a 4. There's 4 pairs of white socks initially. If she wears a pair of socks one day, the next day there's only going to be 3 pairs of white socks left in there. When we multiply across the top. So 4 times 3 is 12. And we're going to multiply across the bottom. 16 times 15 is 240. And then to break that into like a decimal number, we're going to take that 12 and divide it by 240. So if I take 12 and I divide it by 240, I get 0.05. Okay, and we don't have to round that because that is just what comes out in my calculator, so there won't be any rounding. Okay, so when we talk about independent or dependent, it's if they affect or do not affect each other. So I always look at my bottom number. When I'm looking at this bottom number, I have a 16 right here and a 15 right here. So because those numbers are different, it's going to be dependent. They depend on each other. You wore a pair of socks, so the next day there are less in there. So that one would be a dependent probability. So let's look at number 2. Number 2 says, Mrs. Meyer reaches into her sock drawer. She has 4 pairs of white socks, 9 pairs of gray socks, and 3 pairs of black socks. Okay, so our total for this one is going to be the same. So I'm going to just say my total is still 16. Mrs. Meyer reaches in, grabs a black pair of socks, but decides that gray will go better with her outfit, so she returns the black pair. So these are our keywords. If you're going to return the black pair, when you go in the next time, you still have the same amount of socks in there. What's the probability that she gets a black pair, returns it, and gets a gray pair? Okay, so she wants this pair of socks, doesn't like it, and then she wants that pair of socks. So initially there's 16 pairs of socks when she reaches in, but when she returned that black pair because she wanted gray, there was still 16 again because of the return. Okay, so the first thing she gets out is black, and the next thing she gets out is gray. So I'm just going to go up and I'm going to look and see how many pairs of black socks she has. So when I read right there, it says she has 3 pairs of black socks. So my first number is going to be 3. She returned that pair of black socks, and now she's looking for gray socks. And this one says she has 9 pairs of gray socks. So now we're going to use 9 right here. And just like above, we're going to multiply across the top. So 9 times 3 is 27. And then we're going to multiply across the bottom. 16 times 16 is going to give me 256. Okay, if I take 27 and I divide it by 256, I get 0.105. Okay, we round to that hundredths place. So that 0 is going to stay the same, the decimal stays the same, the 1's going to stay the same. This 5 is going to tell me if I'm going to move that 0 to a 1 or if that 0 is going to stay a 0. If this number right here is 5 or above, we say give it a shove. So that 0 is going to turn into a 1. Give it a shove means go up. So it's going to be 0.11. Okay. Now I'm going to look back and look at my bottom numbers. Are these bottom numbers the same or different? Because they're both 16, that means that they are independent because they do not impact each other. They're both 16, so because she put it back in there, she has the same number of socks in her drawer. Okay, let's look at number 3 here. It says there are 32 candies in a bowl. So right away, I know what my total is. My total is going to be that 32. So I'm just going to start with that. There are 8 Starbursts, 12 Snickers, 12 Reese's. However, Mrs. Johnson doesn't like Starburst. What is the probability that Mrs. Johnson draws a Starburst, returns it, and draws a Reese's? So she wants a Starburst. She doesn't like it, so she returned it, and then she gets a Reese's. So this is going to be my line for my Starburst, and this is going to be my line for my Reese's. So I'm just going to write ahead, put Star and Reese's. Okay, it says there's 32 candies in a bowl, so I'm going to start with that 32 because that's how many candies are in a bowl. But if she takes one out and she puts it back in and grabs another one, this one is still going to be 32 because she replaced it. And then I'm looking for, the first thing I want is Starburst, so I'm going to go back up to my reading, and it says there are 8 Starbursts, so this first one's going to be an 8. And the next one is going to be the Reese's, so this one is going to be 12 Reese's. And then we're going to do that same thing. We're going to multiply straight across. So 8 times 12, I get 96. And 32 times 32, I get 1,024. And if I divide those out, 96 divided by 1,024, I get 0.093. Okay, so now looking at those, I want to round to that hundredths place. So I'm going to say 0.0. That 3 is going to tell me, is this 9 going to stay a 9 or is that 9 going to turn to a 10? If it's 4 or less, we say give it a rest. So that 9 is going to give a rest, so it's going to stay just how it is. So I'm not moving that 9 at all. Okay, now I'm going to go back and look at my bottom numbers. If they're the same, it's independent. If they're different numbers, it would be dependent. Because they're the same, it's going to be independent. Okay, let's look at number 5. There are 5 chocolate bars, 8 peanut butter cups in a candy dish. So it didn't tell me the total. So I'm going to take that 5 and I'm going to add that 8 and my total gives me 13. So I know in a dish there are 13 candies. Liz chooses 3 of them at random. Okay, so right away, because she's choosing 3, I know I want 3 lines. What's the probability she chooses all 3 chocolate bars? Okay, so we're going to start with how many total there are. Right away, there are 13. And this is where we have to be thinking about it. If there is chocolate in a dish and you reach in there and you really like chocolate, you're probably going to eat it. So the next time you reach in, there's going to be 12 because you ate one. And then the next time you reach in, there's going to be 11 because you ate one. If she wants chocolate bars all 3 of the times, I'm going to go back and I'm going to find the chocolate bars. And there were 5. So initially there were 5 chocolate bars. She ate one, so there's going to be 4. She ate that one, so then there's going to be 3. If I multiply straight across, I get 60 on the top and 1,716 on the bottom. And if I take that 60 divided by 1,716, I get 0.034. Okay, I want this hundredth spot. So I'm going to keep my 0. I'm going to keep my decimal and my other 0. And then this 4 is going to tell that 3, you're either going to I'm going to give you a rest or I'm going to give you a shove. Because it's 4 or less, I'm going to give you a rest. So that's just going to stay a 3. Okay, now I look at my bottom numbers. If they're all the same, it's independent. If they're all different, it's dependent. They were dependent on each other because she ate some of those. So this one's going to be dependent, and that's why those numbers went down. They were dependent on the ones that she ate. Okay, number 5 says, 3 cards are drawn from a standard deck of cards without replacement. That means when I take it out, I hold on to it. So I don't put it back in the deck. Find the probability of drawing a heart, another heart, and a spade in that order. Okay, so that tells me how long or how many lines I need. So I want a heart, I want another heart, and I want a spade. So I'm going to say this one is heart, this one is a heart, and this one is a spade. Okay, when we talk about cards in a deck, there are 52 cards in a deck. So I'm going to, oops, hold on a second. Got a little ahead of myself. There are 52 cards in the deck. So that first one, we're going to have 52. But then you have these words right here that say without replacement. Like I mentioned before, if I take it out, I'm going to hold it in my hand. It's not back in the deck. So the next time I go to reach in the deck, there's only going to be 51. And then if I reach in the deck again, there's going to be 50. Okay? So if I want a heart, when you look at how many hearts are in a deck, there are 13 hearts. But if I grabbed a heart out that first time, now there are going to be 12 hearts. And now I have to look at the spades, and there will be still 13 spades in my deck of cards. So if I take all those, and I have 13 times 12 times 13, I get 2,028. And if I do 52 times 51 times 50, this is going to be a big number, 132,600. And if I take both those numbers, 2,028, and I divide it by 132,600, that gives me with 0.015. Here's my tenths place. I keep my 0, my decimal, my 0 the same. I look at this 5. This 5 is going to tell that 1, 5 or above, give you a shove, so you're going to turn to a 2. And now I look at those bottom numbers. When I look at these bottom numbers, they're all changing, so this is going to be dependent because the bottom numbers are changing. They're dependent on each other. You kept your card in your hand. You did not put it back. Okay, let's do this last one. So find the probability of drawing 2 cards. Both cards are club, and this one says with replacement. So I want 2 cards. So I want this and I want that. And it says both are a club. So I want a club and I want a club. Okay. And with replacement means it starts out with 52 cards. I pull one out, I look at it, and I put it back in. So this next time is still going to be 52 cards. When you talk about cards in a deck, there are 13 clubs in a deck. If I looked at it and put it back in, there are still going to be 13 clubs in a deck. Okay, so if I do 13 times 13, I get 169. And if I do 52 times 52, I get 2,704. If I take 169 divided by 2,704, I get 0.062. I'm looking at my hundredths place. So when I look at that, my 0 stays the same, decimal stays the same, 0 stays the same. This 2 is going to tell that 6, I'm either going to give you a shove or I'm going to let you rest. It's 4 or less, so I'm going to let you rest. So it's going to stay a 6. And then I'm going to look at my bottom numbers. So I'm going to look down here and I'm going to say, were these the same? They sure were. So that's going to be independent because they were the same. Okay, when you are done with this note sheet, you can go ahead and work on the practice. The multiplication, not multiplication, independent versus dependent multiplication, not multiplication, the independent versus dependent review. That's what you're working on.